Hi students, how are you? I hope that you are doing fine. Today we are going to start a new chapter, that is triangle. I was supposed to start some other chapter, but my friend's son Srinath told me that he is not understanding the basics of triangles. So I thought that I will clear his doubts. I have already uploaded many class 10 mathematics videos and the links are already available in the description. If you are watching this video for the first time, please subscribe to it and share it amongst your friends. You have already studied in your previous classes what is a triangle. Triangle has got 3 sides and 3 angles. So today we are going to learn about the similarity and congruency. What is a similar triangle? What is a congruent? First of all, let us understand what is the meaning of similar figures. Now you know that this is a chalk. This is again a chalk. This is a small piece, this is a bigger piece. Now both of them are having the same shape, but their sizes are different. So we can say that these are similar figures. But if we have 2 similar chalks of the same size and same shape, they are congruent because they don't overlap, they have the same size and same shape. Now let us try to understand the same thing as far as the triangles are concerned. Now you can see there are 2 sets of triangles. In the case of congruency, they have same shape and same size. So we can say that they are congruent triangles. But you can see it on the right side, they have the same shape but their size is different. So they are known as similar triangles. Now let us understand similar shapes. On the left side you can see that there are 2 heart-shaped objects. One of them is smaller and the other one is bigger. So they are similar. Now you can see that there are 2 pentagons. 5 sides are there. One is smaller and the second one is bigger. But both of them are having similar shape, but the size is not the same. Now you can see it on the right side. There are 2 basketballs. Both of them are having the same size and same shape. So they are congruent. Now you see 2 sets of pentagons. Now both of them are having the same size and same shape. If you put one pentagon on top of the other pentagon, it will not be overlapping. So you can say that all congruent figures are similar, but the similar figures need not be congruent. Now let us do some of the MCQs. Now the first question is, all circles are congruent or similar? Which one is correct? Similar, because if we put, there may be a smaller circle, there may be a bigger circle. So all circles will be of the same shape. They may not be of the same size. So we can say that all circles are similar. Now second question, all squares, they are similar because there may be a bigger square, there may be a smaller square. So all squares are similar. Now the third one, all equilateral triangles are similar. So equilateral means there are 3 sides and equal sides. They are having the equal sides. So all equilateral triangles, there can be a number of equilateral triangles, they will be similar. The fourth one, 2 polygons of the same number of sides are similar if their corresponding sides are equal and their corresponding sides are proportional. Now let us do question number 2. Give 2 different examples of pair of similar figures and non-similar figures. Now you can see it, there are 2 triangles are there. One triangle is having a side of 2 cm and the other triangle is having a side of 4 cm. So these 2 triangles are having the same shape but sizes are different. So these are similar figures. Now let us understand what are non-similar figures. Now you can see there is a trapezium and a square. Both of them are having 4 sides, but look at their size and look at their shape. They are different. Now let us see the triangle and the parallelogram. Triangle is having 3 sides and parallelogram are having 4 sides. Neither the shape, neither the size are equal. So they are non-similar figure. Now let us do theorem 6.1. If a line is drawn parallel to one side of a triangle to intersect the other 2 sides in distinct points, the other 2 sides are divided in the same ratio. Now this theorem is very important for your exam point of view. This will definitely come either in your semester exam or in your final exam. First of all, let us understand what is the meaning of this theorem. This theorem says if a line parallel to any side of the triangle, now here DE is parallel to BC, then this line DE will cut the other 2 sides AB and AC at the same ratio. That means they will cut the other 2 sides proportionally. We can have a parallel line to AB also, we can have a parallel line to AC also. But for our ease of understanding, we have taken a parallel line DE parallel to BC. Now we have to prove that this DE cuts AB and AC at equal ratio. That means AD by DB, AD by DB is A equal to AE by EC. This is what we have to prove. First of all, let us draw a perpendicular, that is NE perpendicular to AB. We know that what is a perpendicular line? This will have 90 degrees. So we have drawn a perpendicular NE to AB. So this line is there and we have just joined B and E. Now let us consider the triangle ADE. We are considering this triangle ADE or the upper triangle. Now what is the area of a triangle? Half into base into height. That you have already studied in your previous classes. So area of triangle ADE is equal to half into, what is the base? Base is AD. This is the base of this triangle and the perpendicular, that is EN. So half into AD into EN. Now let us consider the second triangle BDE. This triangle, this second triangle BDE. Now what is this area? So here again the base is this BD. And what is the perpendicular distance? EN. That is a perpendicular distance to this line. So area of triangle BDE is half into the base. Base is BD into EN. Now let us divide area ADE by area BDE. So this half into AD into EN divided by half into BD into EN. Now we know that this EN and EN will get cancelled, half and half will get cancelled. What is left is AD by BD. Let us call it as equation number 1. That means area of ADE divided by area BDE is AD by BD. That is equation 1. We got the left hand side of the theorem. Now let us draw a perpendicular DM to AE. So DM is perpendicular to AE. Now consider the first triangle. In the first case we have considered triangle AD. Now again we will consider the same triangle, but here we are taking this side as the base and this is the perpendicular distance. So the area ADE, area of triangle ADE, that is half into base. Base is AE into what is the perpendicular distance? DM. Now let us consider the second triangle, that is DEC, this triangle. In the previous case we have considered this triangle. Now we are considering this triangle. Now what is the area of triangle DEC? Area of triangle DEC is equal to half into, what is the base? Base is EC. EC into, what is the perpendicular distance? DM. Now if we divide these two areas, so what will happen? This half and this half will get cancelled, DM will get cancelled. So what is left is AE by EC. So let it be equation number 2. Now this triangle BDE and triangle DEC are on the same side of D and between two parallel lines, that is DE and BC. Therefore this area is equal to this area. So we can write area of triangle BDE is equal to area of triangle DEC. The reason is this is lying on the same side and this is between these two parallel lines. Therefore this triangle, area of this triangle BDE is equal to this triangle. Therefore their areas are equal. Now you see on the left side area of triangle ADE divided by area of triangle BDE. Here area of triangle ADE divided by DEC, and these denominators are having the same areas. So this area between these two triangles are same. That means AD by BD is equal to AE by AC. So from equation 1, 2 and 3 we can write AD by BD is equal to AE by EC. Now let us have a quick revision of what we learned in this theorem. In this theorem we have to prove that AD by DB is equal to AE by EC. This is what we have to prove. What is given to us is DE is parallel to BC. Now first of all we have drawn a perpendicular NE or EN to this line, and secondly we have drawn a perpendicular DM to this line. First of all we have taken this triangle, that is triangle ADE. Triangle AD we have taken. We know that the area of a triangle is half into base into height. Therefore area of triangle AD is half into base into height. Now second triangle which we have taken is BDE, this triangle. So here again half into base into height. The perpendicular height is EN. So that is half into base into height. Now if we take the ratio of these two triangles, we will get AD by BD. Let it be there. Now we have taken the second set of triangles, that is AD, again the same triangle which we have taken the first triangle, and this triangle DEC. Here we have taken the second perpendicular, that is DM. Therefore half into AE into DM. Now in the second case triangle, that is triangle DEC, half into EC into this perpendicular distance. So from these two, that is this triangle and this triangle, are having the same area because they are lying on the same side of a line and between two parallel lines. Therefore this area is equal to this area. Now from 1, 2 and 3 we can say that AD by BD is equal to AE by EC. Now let us do example number 1. If a line intersects sides AB and AC of a triangle ABC at D and E respectively and is parallel to BC, prove that AD by AB is equal to AE by AC. We have just studied the theorem 6.1. In that we proved that AD by DB is equal to AE by EC. That we have proved. Now what we have to prove? AD by AB, the full length, is equal to AE by AC. This is what we have to prove. So according to the theorem that we have already studied, we can say that AD by DB is equal to AE by EC. That is according to the theorem 6.1. Now we can reverse it, we can put it the other way around, that is DB by AD is equal to EC by AE. I have just reversed it. Now if we add 1 to left hand side and the right hand side, DB by AD plus 1 is equal to EC by AE plus 1. We have just added 1 to LHS and RHS. So this will be DB plus AD by AD is equal to EC plus AE by AE. Now you look at here, DB plus AD, DB plus AD, what is this? This complete distance, that is AB. AB by AD is equal to EC plus AE, that is AC. AC by AE. So we have proved. Now let us do example number 2. ABCD is a trapezium with AB parallel to DC. E and F are points on non-parallel sides AD and BC respectively, such that EF is parallel to AB. We have to prove AE by ED is equal to BF by FC. Now look at this figure. What is given to us is AB is parallel to DC and EF is parallel to AB. We have to prove that AE by ED is equal to BF by FC. Now what is given? AB is parallel to DC and EF is parallel to AB. If AB is parallel to DC and EF is parallel to AB, then EF will also be parallel to DC. Now in triangle ADC, now according to our theorem, EG is ADC, EG is parallel to DC. Now consider triangle ADC. Now in ADC, EG, that is part of EF, that is parallel to DC. Therefore EG is parallel to DC. So EG is parallel to DC. Therefore we can say that AE by ED, that is this by this, is equal to AG by GC. Now consider this triangle ABC. Here this GF is parallel to AB. So if GF is parallel to AB, we can apply theorem 6.1. So in triangle ABC, we can apply theorem, that means BF divided by FC is equal to AG by GC. This divided by this is equal to this by this, because these two lines are parallel. Let it be equation number 2. Now you see AG by GC, and here also we are having AG by GC. If RHS are equal, LHS will also be equal. Therefore AE by ED is equal to BF by FC. This is what we have to prove. Now let us have a quick revision. We have been given that AB is parallel to DC and EF is parallel to AB. Then we have to prove that AE by ED is equal to BF by FC. Now if AB is parallel to EF, this EF will also be parallel to FC. First of all, we are considering this triangle ADC. Here EF is parallel to DC. If EF is parallel to DC, EG will also be parallel to DC. So we can apply theorem 6.1. That means AE by ED is equal to AG by GC. Now we are taking the second triangle, that is triangle ABC. Here EF is parallel to AB, therefore GF is parallel to AB. So we can apply the same theorem. So BF by FC is equal to AG by EC. Now AG by GC is same on the right hand side, therefore the left hand side will be equal. So while equating the left hand side, we get AE by ED is equal to BF by FC. This is very simple, because in the first case we have taken this triangle and the second case we are taking this triangle, and we are having the same line AC. So by making use of this line AC, we have proved it. So today we have studied the introduction to the triangles. Basically we have studied about the similarity of triangle and the congruency. Then we have studied a theorem, that is theorem 6.1. Then we have done 2 examples. I think it is very clear to you. If you have any doubts, please send your queries in the comment section. Thank you.